All right.
Right.
Cool, Christophe. So, what do you think? We're here. Well, first of all, I'm here with Christophe, designed the L2 system for L-Acoustics, and this is the first North American deployment of it. And he's out here from France and checking it out and getting to hear his creation in action with a wide variety of bands, which is super fun. And yeah, I'm excited. So, what do you think so far?
So far, first of all, thank you very much, Dave, for having L2 at Coachella. It's really incredible to be here and to hear all these good songs everywhere. And this first deployment is really interesting. It's a 2 L2 box with 1 L2D.
Okay.
And we cover from 2 meters to more than 50 meters.
Okay.
And and we discover the possibility of the system. So it's really fun.
Right. So this is a different. You did deploy it in Europe, but I believe that was a 4.
Yeah,
three L2 and 1
absolutely.
L2D.
But since here it's more like a greenfield situation, and with a delay tower, then we have a downside angle 5 degrees.
Okay.
And then with 3 box, we have enough SPL and enough curvature. And even we use the new Autofilter algorithm.
Okay.
Because of the DNA of the system, we have a high resolution control on the system, each waveguide.
So describe the autofilter.
Sorry?
Tell me about the autofilter.
Yeah. In fact, since the boxes, in each box we have 8 drivers.
Okay.
That are in a fixed, non-constant G shape. And since they are really precisely together with no gap, no splay, and no tolerances.
So there's no spaces between. It's smooth all the way down, and you have 8 horn drivers.
Yeah, exactly. Perfect line source, and no tolerances. Everything is predictable with Soundvision, and then we can use a high-res autofilter, 1 DSP per waveguide.
Yes.
And then we can control much better the sound field
so that gives you modifications of the vertical.
Absolutely. Yeah.
Control.
And we do all that with Soundvision. And so far, from all the use we have done with L2, and especially here, we see that the result as expected in Soundvision, and we almost have then no EQ on the system.
So this is the first time you've really brought Soundvision in as the controlling software for a box.
So not only it's a modelization, it's as you say, a control software, and the algorithm, Soundvision, is totally part of the system.
Yes,
it's a must with the system.
So you're designing your array, you're putting in your venue, and also controlling what your system's going to do. Instead of exporting in.
Absolutely, and you know. What you say is very interesting, because in fact we have designed the shape, the physical shape of the system based on what we could do with the algorithm. So we have studied a lot the possibility of algorithms that are modern today, magnitude and phase control in all the bandwidths, and we try to acknowledge what at L-Acoustics we were ready to let the algorithm do and not do to ensure the best result. And once we have focus on these possibilities that the algorithm gave without any compromise, then we have designed the shape, the physical shape, to be the best match with the potential of the algorithm. So it's really kind of new.
That's great. So the top boxes, the L2s are 10 degrees naturally.
In fact, it's a 10 degree on the cabinet, but inside the age waveguide, they start at 0 degree.
Okay.
And then they finish at 2 degrees. So in fact, it's a J shape.
Okay, yeah. So there is a J built in.
Yeah, absolutely, to help to throw better.
Right.
And then they couple together. And so it's 2 J shape that couple together and are controlled by the algorithm. And this is the core of the
So you can kind of modify that J a bit with the algorithm to smooth it out.
Since everything is fixed, predictable, then we can control that with the algorithm.
Right. You're able to put in a lot more precise control and know what's going to happen, because you don't have to compensate for 5 degrees between the box or 2 degrees. Everything is locked.
Exactly.
Now the bottom box is 60 degrees naturally.
Yeah, absolutely.
But again, you have additional control, right?
Again, the same concept. It's a 60 degree box. and we start the waveguide angles at 2 degrees and we finish at 18 degrees.
Okay.
So all in all, the 8 waveguide create a 60-degree J shape.
Okay.
Totally optimized for all application. So for downfield application when you have L2, but you can also use that just to cover 60 degrees if you need. It's perfectly matched like a theater, 60 degrees. If you need to do like a classical ELISA show in high resolution, for example, you could just put one L2D.
So you have instead of it being beamy up top and losing volume, you can soften that and make it more straight and make it more, kind of convert an L2D more into an L2-ish.
If you need, of course, if you need only 10 degrees, then it's better not to use the L2D. But if you have less curvature than the L2D can provide naturally, then once again, you use the algorithm Autofilter. And in Soundvision, you move D min, which is the starting point of your coverage, further away. And the algorithm will automatically fade out the waveguide.
Wow.
So, and the nice thing of it is that you can even adapt on field. If you have a rig system and you need less coverage or a little bit more, if you cover more than the starting point, then you just move that in Soundvision, press Autofilter, and then import in.
Now, does the Autofilter update silently, or does it require a mute?
In fact, you will always do the modelization, the update of the modelization in Soundvision.
Okay.
And then you will use the network manager synchronize zoning group synchronization feature just to upload the new filters.
Okay, great.
So modelization is offline.
Yeah.
Always important because it can take time. You never know. You don't want to stop your show. But the import, the synchro is real time.
So that gives you the versatility. So you have a fixed angle mechanical, which you get close to what you need, and then you finish it off with electronic steering, electronic control to optimize it. So you've kind of taken the best of both worlds, because there are sound systems that do pure electronic optimization or control, and there's ones that do pure mechanical.
Yeah.
And this has taken an optimal mechanical angle and then added electronic optimization to fine tune.
Yeah, it's really, really nice because with the hardware design, we have managed to make the best line source possible.
Okay, so with that, you're talking about eliminating all the division
gaps,
points. You've dropped from 11 gaps, like 12K2 would be 11 gaps, and you've gone to 3.
Oh, yeah. Absolutely. Yeah. And so this helps a lot. The starting point is really, really good. And then with the algorithm, we control in a high resolution, in frequency, magnitude and phase to the full band to then ensure the best SPL coverage in the audience. And what is really nice is that, as you said, we have taken, I think, the best of both worlds, the best of the hardware, the pure line source, and the best of the algorithm to not do full control just with algorithm, because we know that it's not working. It's an addition to refine.
Making small adjustments in the electronic domain can be very effective, but doing large adjustments has a lot of negative ramifications.
This is what we conclude. And at the end, this is the core of this new, what we call pulse technology. And this is the basis of a new design, a new range of system, and this is what we have more or less patented for us. It's the fact that we couple non-constant, fixed curvature array, and we control that with steering. And then in the horizontal, since we have Panflex, we are not blocked.
Right, because you've got the Panflex is the horns that you can adjust. You can go, now these go from 110
to 70.
To 70, and you can go asymmetrical, and everything's adjustable except for the bottom 4 drivers, which is the bottom half of the L2D.
You notice that? Yeah, the bottom of the L2D
is fixed wide.
It's fixed, and it's going from 110 to even 140, like SIVA coverage.
Oh, so it actually gets wider than 110 at the bottom.
To ensure mainly better coverage coverage in the near field, and also for ELISA deployment to have a better coverage zone.
And also, you're typically very close, so you need that wider coverage. As you go farther away, you want to narrow the coverage because it actually covers the same width of the audience.
Absolutely. And Panflex is a must for this new design, because otherwise, how could you do to have a big wide-angle box or a smaller one if you cannot change the box with them? So Panflex is really linked to the design.
That's very important because, if you have it wide up top, you lose all your energy. You can't focus it far. It bounces off walls, and this gives you the ability to clip it off the sidewall. Now, let's talk about the actual design. Now, I mean, as someone who's designed systems myself, the things I look at are size, weight, cost, sound quality, max volume, and ergonomics and handleability. Those are the 6 parameters that I look at.
Time of deployment.
Yes, and I put that into ergonomics, the ability to set it up, and also aesthetics. So you could add that as a 7. So looking at this design, like comparing to K2, which is a good reference point, is a very high demand, high quality box. Here's a box that is smaller.
Absolutely.
So you got the size thing. You've dealt with the size. Lighter.
Yes. Yeah. When you compare to, if you compare to 4K2, it's lighter. So more or less, we are in between 25 to 50% of reduction of all the KPI you have expressed.
25 to 50% benefit.
So the starting point of the design of this system was also to optimize ELISA deployment. And what is really great with ELISA is that it forces us to be better, because we need faster deployment, smaller height, smaller weight, and with absolutely no compromise on the sound.
Okay, so you were able to do that. I mean, usually when you optimize one parameter, you lose another. If you make it smaller, it tends to not be as loud. If you make it louder, it tends to not sound as good. But here, it looks like you pretty much made it smaller, lighter, definitely sound better, and reduced weight, and the compromises are...
Alors, there is one maybe compromises, is the bandwidth. So, compared to K2 and K1, of course. So the K2 and K1 are 42 hertz tuning box, and this one is around 60.
Okay.
So
you lose a half an octave on the box.
Yeah, absolutely. So the starting point has been the SPL per meter to reduce the height, and the SPL per meter, it's linked to the height of the waveguides and the strength of the compression driver, and this is K1 grade. So the SPL per meter in the HF is like K1.
Okay.
So this is a starting point to do the best possible in terms of reduction of height. Then we have dimensioned the low mids with 10 inch, because we wanted not only to have this, to follow the SPL of the K1 SPL per meter, but also to give contour to the box, because we wanted the box to have the 10 dB contour at 100 Hz and down to almost 15 dB at 60 Hz to be able to do any kind of application.
Right.
So we have done that with the 10-inch LF drivers tuned around 60 Hz to have the SPL, the impact, and we have added also the 12-inch on the side for both the contour, because they contribute to the global contour of the box, and also for the Cardioid design. Maybe we talk about that later.
Cardioid. Okay, so this is the first dive into 10 inches for L-Acoustics, which is interesting.
We are the ARCS A10.
The A10. Okay, that's
but you're right.
Yeah. In a main PA box.
The most popular size.
And so these are Cardioid.
And you know what? Because it matches perfectly right now the size of the 10-inch with the two driver.
With the high frequency drivers.
Yeah.
Now, so this has Cardioid control as well, and there's more than one setting. It's not just a single choice, right?
Absolutely. So we have designed. So we wanted to have the low frequency contour and the cardio capability, and all that embedded in a shallow box. So the 12-inch, they are mounted internally in the box on the side.
Okay.
But we have a side panel in front of them.
Okay.
We call that, it's a low frequency acoustic waveguide, more or less.
Yes.
And in fact, the 12-inch are firing both front and back.
Okay.
And since all the box is totally active, by the way, it's because we use the 16 channel of the new amp,
Yep.
the LA.16. So we have, it's important I say that because we have 8 channel of driver, then 4 channel of dual
Of the
10
12.
inch.
So, okay, 8
And
channels.
then the
Every horn driver's on its own amp channel.
Every driver,
pair of 10s is on its own
Absolutely,
amp channel.
yes.
And then each one of the 12s is on its own amp
Absolutely.
channel.
So we have this configuration totally active that allows us to fine tune the alignment on the front. So our design, where the sound is coming from, exactly from the front, close to the 10-inch and to the back,
Okay.
allows us to perfectly time align the 12-inch and the 10-inch on the front,
Okay.
while ensuring a very good 20 dB rejection at the back. We also have the port of the 12-inch that's
Okay.
firing at the back to enlarge the distance at the lowest frequency between the front and the back to ensure
Okay.
the best, the full range cardio. So, and it's really great this, and we discover the possibility of the cardio, to be honest, because not only we have cardio presets, but we have also super cardio.
Okay.
Since we are active, we can
Right.
play with this. And so far in stereo mode, inside, always the super cardio give a better new kind of sound, because not only you have better resolution on stage with the
Right.
stereo, with super cardio, because the maximum cancellation is at 120 degree, not 180.
Yes.
Plus, in addition, on the other side, you avoid the first reflection to the walls or whatever.
Right,
is
right,
there.
right.
And what we discover is how, dry is the sound in the low end. So we keep all the impact from the native 15 dB contour of the box without...
It sounds clearer
the
and
rooms.
punchier. Yes.
And this is what we figure out. And right now we prefer to use super cardio in stereo inside, but I'm sure that with ELISA deployment it will be cardio the best, because
Because above, yeah, you're
since
directly
it's
behind.
frontal, cardio will be
I run
probably
into
the best.
that with microphones. A lot of cardioid microphones are good for one wedge.
Yes.
And super cardioid wedge microphones are better if you have two wedges.
Exactly.
And you
So,
got the kind of similar
same
setup.
conclusion. Yeah, absolutely. So it's kind of exciting,
Very-
to be honest.
Awesome. Cool. Well, it's great talking to you. This is super exciting. It's great to see you again. I saw you in France last when this was early on. And
Yeah, you're right.
we got to hang out in Biarritz too. It's cool. Got
It's
some
always
surfing
nice
in.
to hang around with you.
Yeah.
And I have to say, working with your team is super great here. And I would like to say bravo to your deployment of L-Acoustics sound system in Coachella. I'm blown away by what
Awesome.
you
We
do
got
with our
we got like
products.
700 or 800 boxes here.
No, it's unbelievable.
A lot of boxes. It's super fun.
So it's great. And what do you think about the L2? You've been able to listen to it a little bit here.
Yes, I think it's great. I mean, I came in and I spend a lot of my time here at Coachella walking between the various stages and just listening to band after band, making sure the stages don't overlap. I deal with off-site noise and pretty much anything that happens. And walking into this tent, it's clear. You can just hear a clarity, mix after mix. I mean, there's various
Great.
engineers. It's definitely a noticeable difference, walking
Okay.
between the various tents. There's a clarity differential. The clarity and definition, stereo imaging, it's great. I mean, it's
Great.
really
Thank you.
impressive. I'm excited as a PA vendor, looking at something that's smaller, lighter, louder, and sounds better, which is such a difficult combination to hit. But also, one of the big challenges is sightlines, where flying up the PA, you need a certain amount of boxes to get the angles you desire, and a certain amount of energy, and you don't have enough motor weight to get up there, so it's too heavy, or you're able to get it up top, but by getting enough boxes, you're blocking sightlines. You have to fly things higher. So being able to, like for wraps on an arena or in small clubs and theaters, to be able to run this down lower if we desire to without blocking the visuals, that's a big advantage.
Yes, that's great. And it's where L2D is really useful, because by design it does the correct job immediately in a little bit more than 1 meter.
Yeah.
You cover all your downfield.
And then setup time. I mean, instead of setting up 12 boxes and having 12 connections, bar, and then 11 down, with 11 jumper cables, 11
No.
cables,
Here it's easy as hell. You have
Here
just 4 connection points between 2 boxes and 1 cable.
You've got 1/4 mount the clips, 1/4 the cables. It's now let me ask you this: it's got a new connector on it too. It's
Yeah.
now since you have a 16 channel. We didn't talk about the amps.
Yeah.
You've got a 16 channel amp,
Absolutely.
and
So we use a 37-point connector
okay,
and the same grade as usual. And we use 32 of the pins for the 16 channel.
okay,
And it's 1.5 square millimeter. All the boxes are all the drivers are 8-ohm
8
configuration.
ohms, and using approximately 16 gauge cable.
Yeah, and-
The metric equivalent of 16 gauge. Slightly thick rubber.
And with this, even with 8 ohm on this gauge, we have less loss with big lengths of cable than we have today with a lot of parallel box in our bigger cable. So really, it's no compromise on this. So in fact, what is new also is that we modelize everything in Soundvision and in Network Manager. So each component of each loudspeaker
Yeah.
has a power demand potential, and we modelize the feeling of the 16 channel in terms of power demand.
Got it.
And so that we have recommendation both coming from Soundvision at the design stage and in Network Manager operation stage, so that you do not overload your
So
your
when
amplifier.
using the LA 7.16 for other things besides the L2, Soundvision will look at what that product draws
And it
and
will
make
tell you
recommendations
how far
of
you
like
can
don't
go in
put
feeding the beast,
and
yeah.
it will cheat you in the right direction
absolutely.
and guide you to optimize your answer.
Yeah.
So compared to L2, where if you put 2 boxes per LA12X, if you have K2 on
K2.
LA12s,
K2, you can put 4 boxes in
On an LA12.
on one on the LA7.16.
you can put 4
4
boxes
K2.
on
Yeah, 4
a 2
K2.
rack space amp.
Yeah,
So you
that's-
get 2 boxes per rack space.
Plus you get 1 DSP per K2 for the autofilter. Plus
With
the-
this powering system, your actual amp racks, you have 50% of your rack space from amplifiers.
Yeah, and this is really the optimization we have been able to do because we work closely between electronics team and acoustic teams. And
Because you guys own the amplifier manufacturer.
but so for sure, LA12X big power amplifier. It's also here to feed a lot of subwoofer for home. So for sure, here the new amp will not be able to feed a Case28 for home. It's
Right.
another kind of scenario. You can feed 8 subwoofer, but 8 ohms, like Case21.
Got it.
Okay? But and now, but for K2 or for L2, in fact, the long-term big power demand is lower than this capability. So it's far enough with this new amplifier.
Wow. So the LA12X is a high current, lower voltage amp, or a high voltage amp, and the LA 7.16 is a high voltage, lower
current, but
Yes.
adapted to 8 ohm.
Adapted to
designs.
8 ohms,
Yeah.
which then thins your cables up and maintains the fidelity through the
Absolutely.
longer cable
Yes.
runs. Wow. All right. What else? Is there anything else that's exciting? I mean, it's small. It sets up fast. It's cool. Everybody's the engineers have been super happy.
You know what? So far, the feedback we have are even above my expectation, because they all say how present it is,
Right.
impactful, and the HF is so smooth. This is what I hear. And when so far with the 3 different deployments we have been able to do so far, as far as I know, there is almost no EQ. So you
Right.
modelize, open in Network Manager, and then almost no EQ. It's ready to go. So this will add to the time saving.
That's great. So you have a bunch of engineers who are not hiring the system. They're walking into a festival. This is the system that we're supplying. And they've never used it before. They have their setups, their program, their presets for their consoles, and they're not doing a lot of EQ. They're not messing around with it. It's just they're firing it up and it's showing up
absolutely.
familiar and well.
From
for them.
what I saw, it's just like a few taste EQ. If they play loud, maybe they have a little decrease around 3K. But this is like taste EQ. And from the measurement, I can share the measurement of what we have done here in Mojave's tent. I mean, when you see the measurement from 3 meters to 50 meters, they are in 3 dB and they are nothing to do in VHF.
That's so cool.
So,
all right.
so it's great.
Well, this is fun.
So I'm looking
and I get
forward
to
the
hang out with you.
next,
Also,
the
I
next
get to
use
hang
of
out
the
with you.
system and the next feedback you may have. So.
Yeah, we're gonna have to order a bunch of these. I think we did. I put in a PO for a big pile.
Okay,
of them.
great.
Yeah, man. Another $1 million. Bye bye.
All that for good sound.
Yeah.
It's
cool.
a pleasure, Dave.
Well, let's
Thank
go
you
walk
very
in.
much.
We'll walk in and take a look at the system, and then get back to it.
Great.
Go take a look at the rig.
We'll see if we can go close.
We'll see how
because
close we
it's-
can get to it.
It's crowded.
So, how much power was that amplifier? That LA7.16?
Yeah, it's really a beast. You can have 1.2 kilowatt per channel short term. That leads to 20 kilowatt for the full amp short term.
Okay.
And then for the very long term, for the big notes,
Yeah.
then it's 7 kilowatts. And that's why it's called LA7.16.
Right. So it's up to 7,000 watts a channel, and it's 1.2 kilowatts
Per channel.
Yeah, per
Yeah.
channel is its baseline
Absolutely.
power. Wow.
So it gives us the possibility to have a high transient
Yeah.
for the snare and the medium, for the vocals, etc. And for the long bass, for EDM, etc. Then we have the 7 kilowatt. And in fact, for L2, we use a little bit more than half the potential. So
It's still got
so
plenty of room to spare.
no problem. Yeah, we have room for
Awesome.
ideas, you know.
Cool. Let's go check out this system. Cool. So there it is.
Yeah, there it is. And you see, so we have -5 degrees on the top. Then
Yeah.
2 L2, 1 L2D.
Yeah.
And then with the algorithm, we have the fade out of the sound after the third driver from the bottom.
Wow. And that's the equivalent of 12K2.
Yes, absolutely. So.
Look how small that is, and beautiful. It's good looking as well.
It's good looking.
Yeah.
No more pins, all flush rigging.
Yeah. There's no pins on the side, which is great. Everything pops up